Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS3551 Distributed Computing. The unit is Logical Time and Global State. In this video, we are going to discuss about a framework for a system of logical clocks and scalar time. A framework for system of logical clock. A system of logical clock consists of a time domain T and a logical clock C. Elements of T form a partially ordered set over a relation. This can be represented as less than simple. This relation is usually called the happened before or causal precedence. The logical clock C is a function that maps an event E in a distributed system to an element in the time domain T, denoted as C of E. This can be represented and is defined as follows. C, that means the logical clock is represented as H tends to T, such that the following property is satisfied. There are two events, that is EI and EJ. EI tends to EJ, that means EI occurs before EJ occurs. That is, the logical clock of the particular event C of EI is less of C of EJ. That means the event occurs EI. After that, the particular event EJ occurs. A framework of a system logical clock also consider the monotonicity properties is called the clock consistency condition. When T and C satisfy the following condition for events, the particular events EI and EJ, EI tends to EJ, the system of clocks is said to be strongly consistent. Implementation of logical clock requires addressing the two issues. First one is the data structures local to every process to represent the logical time, and a protocol to update the data structure to ensure the consistency condition. Each process PI maintains the data structure that allow it the following two capabilities. A logical clock denoted by LCI that helps process PI measure its own progress. Implementing logical clock. A logical global clock denoted by GCI, that is a representation of process PI's local view of the logical global time. The protocol ensures a process's logical clock and thus its view of global time is managed consistently. The protocol consists of the following two rules. First rule is the rule 1 is this rule governs how the logical clock is updated by a process when it executes an event. Then second rule is this rule governs how a process updates its global logical clock to update its view of the global time and global progress. Systems of logical clocks differed in their representation of logical clock and also in the protocol to update the logical clocks. The next one is the scalar time. The scalar time, this can be proposed by Lamport in 1978 as an attempt to totally order event in the distributed system. Time domain is the set of non-negative integers. The local clock of a process PI and its local view of the global time are squashed into one integer variable Ci. The rules R1 and R2, that means rule 1 and rule 2 to update the clocks as follows. First rule becomes: before executing an event, process PI execute the following, that is CI. The logical clock equal to CI plus D. D is always greater than 0. In general, every time rule 1 is executed, the D can have a different value. However, typically D is kept at 1. Then next, the rule 2, each message piggybacks the clock value of its sender at sending time. When a process PI receives a message with a timestamp C message, it executes the following conditions, that is actions. First, CI equal to maximum of CI comma C message, that is the maximum of the logical clock can be considered as maximum time taken by the particular CI comma C message, then execute R1. Then next one is the deliver the message. The figure shows the evaluation of scalar time. This is the evaluation of scalar time. This is the space time diagram for a distributed execution. Here there are 3 processors involved. First one is the P1, P2, P3. Then this is the scalar time representation for the particular process. Then basic properties of the scalar time. First one is the consistency property. Scalar clock satisfies the monotonicity and hence the consistency property for event, that is the C of EI less than C of M. The total ordering. Scalar clock can be used to totally order even in a distributed system. The main problem in the totally ordered event is that 2 or more events at different process may have identical timestamp. Next property is the even counting. If the increment value D is always 1, if the scalar time has the following interesting property. First one is that if the event E has the timestamp H, then H minus 1 represents the minimum logical duration counted in the unit of events recurred before producing the event. We can call this is the height of the particular event E. In other words, H minus 1 events have been produced sequentially before the event E regardless of the processes that produce this event. Then next property is the no strong consistency. The system of scalar clock is not strongly consistent, that is for 2 events, that is EAN event. If it is not equal to the particular relation with EI tends to EJ, then this is no strong consistency. The reason that scalar clocks are not strongly consistent is the logical local clock and the logical global clock of the process are squashed into one, resulting is less than loss causal dependency information among the events or different processes.